Hello everyone, I am Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. In this November lecture series, we are discussing about the topics under biocontrol system here. And now we are going to discuss about signal flow graphs. What do you mean by signal flow graph? Why it is needed? What is the purpose of signal flow graph? Any idea? Okay, let me start first. Signal flow graph, it is a graphical representation of algebraic equations. Here, the block diagram reduction process takes more time for complicated systems. So, we'll go with signal flow graph. So, to overcome this drawback, use signal flow graphs. Graphical representations is done where the calculation of transfer function is just by using a Mason's gain formula without doing any reduction process. We simply apply the steps in signal flow graph and we'll calculate the transfer function with the help of Mason's gain formula. It is a simple thing. So we'll go with signal flow graph instead of block diagram. Okay, see here the basic elements of signal flow graph. See the example diagram. Here we have y1, y2, y3, y4 and also we have A, B, C and D. What is that? What is node? See here in this part, see what is node here in this signal flow graph. Our input node, also we have output node, branch and we have open path. And what is input node? First of all, what is node? Node is a point, we know that very well. Input node, it is a node which has only outgoing branches. Okay, and output node, it is a node which has only incoming branches. And here branch is a line segment which joins two nodes. It has both gain and direction. And open path starts at a node and ends at another node. See. Forward path. It is a path from an input node to an output node that does not cross any node more than once. And individual loop, it is a closed path starting from one node and after passing through the graph arrives at the same node without crossing any node more than once. And what is non-touching loops? If a loop does not have a common node, then they are said to be non-touching loops. See here. Your y1, y2, y3, y4 is your forward path in this example diagram. And individual loop is, it starts with y2, y3 and again it ends with y2. Okay, and non-touching loops means if a loop does not have a common node, then it is called as non-touching loop. Here we have only one, here we have only one loop, so there is no non-touching loops here. Only one loop, it is also a loop and also it is a non-touching loop. And if we have two or more than two loops, that time we have non-touching loops clearly. And here in this basic elements of block diagram as we have blocks. Here our transfer function is g of s and our input is x of s and output is y of s. Here the output transfer function y of s, it is equal to g of s multiplied with x of s. Here the summing point, here we have cross symbol over here and we have either plus plus or plus minus. Here the output is y equal to a plus b, or if it is plus minus, the output is y equal to a minus b. Okay, here we use Mason's gain formula, and Mason's gain formula, the formula is T equal to C of S by R of S, it is equal to summation I equal to 1 to n Pi del I by del, where C of S is the output node, R of S is input node and T is the transfer function or gain between R of S and C of S, and Pi is the ith forward path. And what is that del? Del is equal to 1 minus sum of individual loop gains minus sum of gain products of all possible non-touching loops and minus sum of gain products of all possible 3 non-touching loops, and it goes on like that. So with the help of signal flow graph, we'll solve this formula to get final transfer function of a system. For same thing, here the formula is summation I equal to 1 to n pi del I by del. So here we have to calculate the forward path first, and individual loops, individual loop gains, and non-touching loops and non-touching loop gains. It is enough to calculate the transfer function of a particular control system. Okay, how do we convert block diagram reduction to signal flow graph? Here we have some steps to convert BDR to SFG. Here first, represent all the signals, variables, summing points and takeoff points of block diagram as nodes in signal flow graph. And second thing, represent the blocks of block diagram as branches in signal flow graph. And third thing, represent the transfer functions inside the blocks of block diagram as gains of branches in signal flow graph, and connect the nodes as per block diagram. And if there is a connection between two branches but there is no block in between, then represent the gain of the branch as here 1. And for example, between summing points, between summing point and takeoff point, between input and summing point, between takeoff point and input. Okay. See here how a block diagram is converted into signal flow graph by following these rules. See here our input RFS and output YFS, and also we have gains G1, G2, G3, G4, G5 and H1, H2, H3, and it is converted into signal flow graph by following the above rules. Thank you.